Welcome to Module 7. This week we will be covering multiple regression. Specifically, we will be covering interpreting the beta estimates as well as performing some hypothesis testing for those beta estimates. And we will see how some of these tests can help us identify the significance of the model. This is something that students will likely be doing for almost every multiple regression model that they will encounter, and this is also a part of the project that is due this week. So I have with me Professor Wan, and we will both be going over some examples and explaining some of the conceptual details. In section 7.4 of Zybooks, where we will be interpreting multiple regression models, let's take a look at this example 7.4.1, and let's see how we can solve some of these problems that require interpretation of multiple regression models. So let's go ahead and read this problem. So here we have the body fat data set and a model where the response variable y is the percent body fat and the predictor variables are triceps skin fold thickness, mid-arm circumference, which is x2, and the other variable is coded as x1. And the sample multiple regression model is given by this equation right here. So y hat again is the predicted y equals 6.792 plus 1.001 x1 minus 0.431 x2. Now, first things first, recall that this 6.792 is the y-intercept. 1.001 is the slope for the variable x1, and minus 0.431 is the slope for variable x2. Now, the questions are, for each question below, state the units and the practical interpretation of the quantity. All right, so what is the estimate for the intercept parameter? So just like we said, the estimate for the intercept is 6.792. Now, what is its interpretation? So Professor Wan, looking at this multiple regression model, we have 6.792 as the intercept. And the question is, how do we interpret this, this value here? What does it mean?
Okay, so in this particular case, that says that when x takes a value of 0, the y-intercept, if we were to continue the straight line, it will cross the y-axis at 6.792.
That is correct. And so when x1 and x2 take values of 0, meaning that the triceps skin fold thickness is 0 and the mid-arm circumference is 0, the expected value of y will be 6.792. Now, does that make sense? The question is it a practical scenario where x1 and x2 can be 0? Well, the issue is that body measurements x1 and x2 technically cannot be 0. And so although 6.792 here is the y-intercept when x1 and x2 are 0, practically this value does not have any meaning. In some instances it will have some meaning, but in this case it does not. Let's take a look at the second problem. What is the estimate for the slope parameter with respect to x1, and what is its interpretation? The slope estimate for x1 is 1.001. So Professor Wan, how do we interpret this value 1.001 that is given in this multiple regression model?
That means that for every change in the x-axis, y will increase. The difference in the increase in y will be 1.001.
Correct, provided that x2 remains constant.
Correct.
Good. So what this means here is, since this is the slope, then a unit change in x1, so say x1 goes up by 1 unit, provided that x2 remains constant, then the change in the estimated value of y here will be 1.001. Now practically what does that mean? Well, what it means is that each time the triceps skin fold thickness goes up by 1 unit, then the body fat percentage will go up by 1 unit, provided that the mid-arm circumference remains the same. Similarly, we can interpret the estimate for x2. The slope estimate for x2 is minus 0.431. How do we do this interpretation? Well, what this means is if we keep the triceps skin fold thickness the same, then a unit change in mid-arm circumference, so if the mid-arm circumference here goes up by 1 unit, then the body fat percentage will drop by 0.431. Now, one of the outputs in multiple regression will be what is called the ANOVA table. And the ANOVA table can be printed using sm.stats.ANOVA-LM method. This is in stats models.api submodule. It has 2 rows. One is for the regression and the other is for the residual. And the columns, the first one is called sum underscore SQ, meaning it's the sum of squares. The second column is df, which is the degrees of freedom. The third column is f, which is the f value, and then the last column is probability or the p-value for that f statistic. Now, f statistic and the p-value is what we all know. That's for testing the overall model. We covered this last week as well. This is also printed in the regression output that we saw last week. However, sum of squared column for the regression and sum of squared residuals, these are something new. So what are these? Well, we look here that sum of squared regression, or SSR, is that it represents the explained variation in the data set. The multiple regression model will try to fit the data set that you have, and in the process of fitting that data set, it will be able to explain a portion of the variation in the dependent variable, and it will be unable to explain the other part of the portion for that variable. And so what you want is you want the regression model to explain as much of the variation as possible in the dependent variable, but certainly will be very hard to explain 100% of it. Residual sum of square, or SSE, sum of squared errors, is that it represents the unexplained variation in the data set. So now, like SSR explain the or represents the explained variation in the data set that is explained by the model, SSE is the other portion of the variation that is not explained by the model. So this is the sum of squared errors. And then you have the total sum of square, SSTO, which is simply just the sum of the SSR and the SSE. We go back to the analysis of variance table here, and we see that we have the sum of squared regression and sum of squared residual, or the SSE. The degrees of freedom are given here, and then the rest is just the f value and the p value. And I encourage you to go through some of these definitions here, and then work through this Python practice 7.4.2 to get to know the analysis of variance table a little bit more. You're not expected to know this for the project, but this is something that you should know as part of the multiple regression modeling.
Now that we're going into hypothesis tests for multiple regression, what is the meaning of the overall f-test compared to the individual t-test? When do you use each one?
Excellent question. Okay, so now that we are on section 7.5, that is about testing multiple regression parameters, hypothesis testing for multiple regression. There are really two kinds of tests that are very important here. One is what we call the overall F-test. And just like it says, here we're just testing the overall significance of the model, meaning that is the model significant at all? What does it mean for the model to be significant? Well, what it means is that at least one of these betas for these variables x1, x2, or any other x variable, at least one of these betas have to be non-zero, right? If they're considered to be zero, then you don't even have a multiple regression model. So when we talk about the overall F-test, we're talking about the overall F-test being significant, which means that at least one of these independent variables can be used in a regression model to predict y. This is why the null hypothesis is that all of the betas, beta 1, beta 2, all of the betas are zero, and therefore the model is not significant. The alternative hypothesis is that at least one of these betas is non-zero. So if at least one of them is non-zero, then we can create a regression model that can predict y. And that's when the model is significant. The individual t-tests, you'll notice here that under the alternative hypothesis, we're only saying that at least one of the betas is not zero. If we reject the null hypothesis, we will go with the alternative hypothesis, but that says at least one beta is zero. But we don't know which beta. We don't know whether it's beta 1, beta 2, or which of the independent variable is the one that is significant in the model. Therefore, we have the individual t-tests. We can do the individual t-test for each of the betas, and then we'll figure out which of these betas is significant. For example, the null hypothesis here is that, for example, beta 1 equals 0. That's one case. An alternative is that beta 1 is not equal to 0. That would be one t-test. Another t-test can be that beta 2 is 0 under the null hypothesis, and beta 2 is not 0 under the alternative hypothesis. That's the second case, and so on. We can test all of the betas using the individual t-test. So let's do an example and see how this works. So let's do this participation activity 7.5.2. So in this case, we have a model for cards dataset where y is the quality, which is the response variable, and x1 is the speed, and x2 is the angle. Those are the predictor variables. The question is there a linear relationship with at least one of the predictor variables? Well, we have this output given. So first we will consider the overall F-test. So recall that the overall F-test is testing whether at least one of the two independent variables are significant. And under the null hypothesis for the overall F-test, we have that the slope estimates for x1 and x2 are both 0, meaning that beta 1 equals beta 2 equals 0. If they're both 0, that means speed and angle cannot be used in a multiple regression model to model the quality. The alternative hypothesis is that at least one of the betas of these two are non-zero. So at least one, meaning it could be beta 1 or beta 2 or both. That they are not equal to 0, meaning that at least one of these variables can be used in a model to predict quality. So let's now look at this output, the regression output that you've all seen last week. In that output, you get your F statistic and you get your p-value for that F statistic. So here we get 3.8 e to the negative 13. That's almost equal to 0. In fact, it is equal to 0. Since the p-value is equal to 0, and if we use a level of significance of 5%, then we can see that the p-value is less than the level of significance, much less than 0.05. and therefore we reject the null hypothesis. If we reject the null hypothesis, we're saying that at least one of these two variables, speed or angle, or both, are significant in the model. We don't know which one. We don't know if it's speed or if it's angle or if it's both, but we know at least one of them is significant in the model. At least one of the betas here is non-zero. So that's what the overall f-test tells us. Now, in order to figure out which of these variables is in fact significant, we look at the t-test, the individual t-tests. And you'll see there will be a column in the output. The third column is for t, and the fourth column is the p-value for that t-test. So the third column is given here, and the fourth column is here. This represents your p-values. So note that for speed independent variable, the p-value is 0. And for angle, the p-value is 0. The t-test for speed, the null hypothesis, is that the beta estimate for speed is 0, and the alternative hypothesis is that the beta estimate for speed is non-zero. Because the p-value is 0, it's less than 0.05, so we reject the null hypothesis, and we conclude that the beta estimate for speed is non-zero, meaning that it is significant in the model. So we should use it in the model. Similarly, the p-value here is 0. So we reject the null hypothesis that the beta estimate for angle is 0, meaning that angle should also be used in the model. So we now have a case where we now know that speed and angle both are significant in the multiple regression model, and we should use both.
Okay, Professor Calvi, let's go ahead and review the discussion for the week and see if we covered the questions that are asked, anything besides what you already covered.
Very well, let's go through this. So this week's discussion is on interpreting multiple regression models. This is really an extension of the model that students created last week. You will need to refer to those models that were created in week 6 last week. So let's just read through this. So in this discussion, you will apply statistical concepts and techniques covered in this week's reading. You will not be completing work in Jupyter Notebook this week. So this is very important. There is no Jupyter Notebook for this week. So there's no code involved. Instead, you will be interpreting output from your Python scripts for Module 6 discussion. So recall that last week you ran multiple regression models in Module 6 discussion in Jupyter Notebook. You will refer back to those models. So you'll have to only look at the, generally you'll only have to look at the output that you received when you ran the multiple regression. If you did not complete Module 6 discussion, please complete that before working on this assignment. So if for any reason you missed running the Jupyter Notebook script for Module 6, please go back and run that first. Last week's discussion involved development of a multiple regression model that used miles per gallon as a response variable. Weight and horsepower were the predictor variables. So two independent variables, and the dependent variable is miles per gallon. You performed an overall f-test to evaluate the significance of your model. This week, you will evaluate the significance of individual predictors. So you already covered the f-test last week. I also covered it in the video. This week, you will evaluate significance of individual predictors, meaning you will essentially just be running the individual t-tests for the variable weight and horsepower. You will use output of Python script from Module 6 to perform individual t-tests, and specifically you will look at step 5 of the Python script, which is the step where you printed the multiple regression output. In your initial post, so these are the questions. What is the slope coefficient for the weight variable? Is this coefficient significant at 5% level of significance? And there's a hint that says check the p-value for weight in the Python output. Recall that this is the individual t-test for beta parameter. See step 5. So in this question, the null hypothesis is that the slope coefficient which is the beta estimate for weight, is equal to 0, and the alternative hypothesis is that it is not equal to 0. We look at the p-value, so you will all look at the p-value. If that p-value is less than the level of significance, you will reject the null hypothesis. If the p-value is greater than the level of significance, then you will not be able to reject the null hypothesis. Now the question is, what is the slope coefficient and whether it's significant? So you'll look at the p-value, you'll compare it to the level of significance, and that's how you will reach your conclusion. Being significant means that you must be able to reject the null hypothesis. If you can't reject the null hypothesis, then it is not significant. Similarly, what is the slope coefficient for the horsepower variable? Again, now you will look at the p-value that is for the horsepower, and if the p-value is less than 5% or 0.05, you will reject the null hypothesis that the beta estimate for horsepower is 0, meaning that it will be non-zero, and so this will also be significant in the model if your p-value is less than 0.05. Last week you performed an overall F-test. Why do you now need to perform individual t-tests? What are the differences in interpretation of the two tests? So I think we've covered it very well in this lecture, so I expect that all students will be able to answer this question. What is the coefficient of determination for your multiple regression model for Module 6? Provide appropriate interpretation. So again, if you remember, the coefficient of determination simply just explains how much of the variation in the response variable is explained by the multiple regression model. And we've covered this extensively in the previous weeks, so I expect that you will be able to provide the appropriate interpretation of this statistic. So again, this should be given in the output. Now you have the follow-up posts. So in your follow-up post, you have to interpret at least 2 other students' coefficient of determination and how do they compare with yours? How do the results of your peers' t-test compare with yours? And would you recommend this regression model to the car rental company? So very straightforward questions. You should be able to answer these questions based on what we've covered in this video as well as what is given in Zybook. And again, please make sure to do Module 6 discussion first. If you have not done that, please do that first and then answer these questions, because all these questions rely on the output that you received last week.